Hi, welcome to this Open Security Summit in January 2022. We have Cristian doing another session of the very interesting and powerful project that they're developing at elastisys on compliant Kubernetes, which is one of the cloud foundation applications, and it's a very good example of how to build Kubernetes solutions that have a huge amount of security. So over to you, Cristian.
Thank you very much, Dennis, for the introduction, and thanks a lot for having me, Ben, in this forum. So, as you said, my name is Cristian Klein. I am the compliant Kubernetes architect at elastisys, and I'm also doing research on cloud computing at Umeå University, both located in Sweden. And today I'm going to illustrate to you how to use Kubernetes as an engine behind a portable, secure platform, which is not only able to run stateless application containers, but is able to host any kind of platform services such as databases, message queues, and caches. So before the things that I will cover today is pretty much, I'm going to highlight a few trends that I see out there, which are pretty much pointing towards a higher demand for on-prem, non-US clouds, and multi-cloud. Then I'm going to highlight the ideal solution, so a secure and compliant platform, however, one that is able to run on any cloud infrastructure, not just on a selected few. And then I'm going to present our solution, our take on this problem, on how to build a portable and secure compliant cloud platform using Kubernetes. And just to make sure that we agree on terminology, I see the platform as a set of services that are sitting between the infrastructure, so more or less physical or virtual hardware, and the application, so basically your code and your magic sauce. So as a motivator, let me just go briefly through the GDPR storyline and what happened so far. So as most of you might know, GDPR has been adopted in April 2016, and nothing happened until it was enforced in May 2018. And still nothing happened until approximately July 2020, when the European Court of Justice essentially ruled that the US Cloud Act is incompatible with GDPR. And that has sent shivers throughout the whole IT industry, and especially those that are dealing with cloud computing, because they were very much reliant on US cloud providers, both for software as a service and also for platform as a service. And basically, the EU Court of Justice ruled that the need of the US Cloud Act for tapping into personal data for national security reasons is incompatible with GDPR's right to privacy that it confers to EU citizens. And that ruling didn't ban use of US cloud providers. However, they said that additional safeguards are necessary before you're allowed to use them to store personal data. Now, the question, of course, arose, what exactly do you mean by US? Do you mean a US company? Do you mean jurisdiction? Do you mean geography? If I have my data in a data that's located in EU, does that count? And this question was settled in March 2021, when basically a French court ruling said that although Amazon Europe has data centers in France and in Germany, that was what the court decision was about at that time. And although it's a company registered in Luxembourg, since it is a fully owned company by AWS US, it's basically a subsidiary of a company under US law. Hence, for that particular court ruling, they were considering pretty much as under risk of tapping into personal data according to the US Cloud Act. And things from there on have escalated at a rapid pace. So in June 2021, the European Data Protection Board came out with some good news that you're still allowed to use US cloud providers, but they also came up with some pretty bad news, which is pretty much that, well, in order to safeguard personal data, the encryption keys must be outside of US control, which essentially makes many of these platform services pretty much useless. So think, for example, about sending an email using Amazon simple encryption simple email service. The email address may be composed of a first name dot last name, so that's obviously personal data, and you need to encrypt that to make that opaque to AWS. So how exactly are you going to send an email using simple email service if the email address containing personal data is opaque to the platform provider? So it pretty much reduces the usefulness of the platform services that we have been so accustomed to, and that we have been so happy to use and have increased our productivity so much. And of course, people were thinking like, yeah, this is just an ambition. It will never work. They will probably do something about it. But unfortunately, we noticed quite the opposite trend. So in November, just last year, 2021, some Swedish government agencies united around the topic of how to continue with digitalization of the Swedish public sector, but without using US services such as Zoom, such as Teams, such as Office 365, and so on. And they actually have a detailed report with a solution to this problem. And they seem to be taking it very seriously because I participated at a virtual conference of our regulator, the Swedish Data Protection Agency. And they pretty much hosted the whole conference on a Swedish provider owned by a Swedish company with Swedish hardware in Sweden, and so on. So the message is very clear that they're taking these concerns very seriously and they're expecting everybody to live up to them. Now, this is a virtual conference, but based on a time zone in which my presentation is taking place, I'm assuming that some of the audience might come from the UK. And for better or worse, you are no longer part of the EU. So why exactly should you care about GDPR? And there are three situations. Either you have absolutely no business with the EU at all, which is in a way great, but do be mindful about the fact that there is a version of GDPR, it's colloquially called the UK GDPR, which is pretty much the national equivalent of EU GDPR. They're currently pretty much in sync, and for the time being, they're expected to be kind of updated in lockstep. And there is a certain risk that the rulings that have been made as part of the EU GDPR will spill over, and the UK Data Protection Agency will pretty much say like, well, the same reasoning applies also to the UK GDPR. So we're expecting everybody to stick to the same data protection standard. I would be very happy to have a debate on this particular topic and hear your experience out in the question and answer section later in my talk. Now, the second situation is that you sell software to European organizations. And that case, pretty much, it's very clear. If you want the money in the pocket of your customers, then your technological stack will need to satisfy their requirements, which are going to be very much centered around the EU GDPR. And now the third case, which is going to be, let's say, the most tedious for you, is that you run software for EU organizations. So in that case, according to GDPR, you are a data sub-processor, and then you have pretty much no choice, but you need to comply with EU GDPR as if you were part of the European Union. Now, what I see is that the trend is very clear. So the EU demands more data sovereignty, and the question has been settled in court. It's not just about geography, but it's about full control. It's about jurisdiction. And we have already noticed, for example, a Swedish health tech is flocking en masse away from US cloud providers. And this is, of course, very natural because they're dealing with patient data. So they're dealing with medical record. And those are, let's say, the most sensitive information out there that you can have. So they're the most eager to protect them, and also to instill confidence in the public that, yes, their data is protected to high standards and they know who has access to their patient records. However, we have also noticed that the public sector is closely following suit, and also EdTech seems to be very eager to move away from US cloud providers into something that is they have under control, that is within EU jurisdiction. And my prediction is that likely some of these trends are to spill to the UK and maybe other countries. And it's pretty clear that customers are increasingly picky about where their data ends up. So I know more and more people that they're checking when a provider is, when they're shopping for a supplier, they're more and more checking for the privacy policy and seeing, okay, what exactly are you using under the hood? Where exactly is our data potentially ending up? And if they see some keywords or some providers that they don't like, either because they have hard requirements or just ambitions and certain sentiments, they're pretty much going for the competitor, which although might not be as featureful, but if their data protection posture is healthier, then they're going for that. So anyway, I noticed a very clear demand for more on-prem, for non-US clouds, and also for multi-cloud, so that you can run your application on whatever cloud provider is already hosting the data of your customers. So then the challenge is, how do you build a secure and compliant cloud platform, but one that is able to run on any cloud provider? And let me go a little bit more into details about why this is a challenge. So for those of you that are at least as old as I am, let me remind you, why exactly do we have cloud platforms to begin with? Why do application developers love them? Why does everybody adopt them so much? Well, it's pretty much because infrastructure is very complex and is very messy. I have here a picture that I have taken when I was younger. And yeah, nobody really wants to deal with cables and fiber optics and replacing hard drives anymore. You want to outsource that as much as possible. And think about how difficult it is to deal with a rather simple compliance requirements, a business continuity requirement, such as tolerate extreme weather. So without a proper cloud platform, you would pretty much have to install 2 servers in some colocation facilities, and you would need to make sure that these colocation facilities are far enough so that they don't get impacted by the same outage, such as a power outage. But then again, you want them close enough so that, for example, you can do something like synchronous replication, or anyway, so that they kind of feel like the same data center. Then you need to install and configure operating system. You need to configure primary and secondary database. You need to make sure that you set up synchronous replication. You need to install the application runtime. Then you need to deal with, how do I make sure that ingress traffic goes to the healthy data center? And often you would end up with something like BGP Anycast that requires very deep integration with your network provider. I'm pretty sure that I forgot some steps, but anyway, just think about, you have to go through 6 steps before you can finally focus on what you care most about and where your magic sauce is really located, your application. So you have to go through 6 steps before you can finally work on your application and make it tolerate extreme weather. Now, in contrast, if you have a supporting cloud platform, say, for example, AWS RDS, then it's as simple as, you just go to the web interface, or you edit a certain Boolean flag in your CloudFormation template, and you just click on multi-AZ deployment, done. Everything else happens behind the scenes. VMs are being configured in the right availability zones. DNS entries are configured properly in order to point to the masters. Other DNS entries are configured correctly in order to point to the secondaries. And everything just works with failover and everything out of the box. So then you can immediately focus on your application. Now, if you're thinking about it, what actually happens today, or what is the state of today's platform? Well, on the positive side, they allow you to focus on your magic sauce, which is pushing high impact application features faster. They reduce the amount of effort. You need to worry less about managing and setting up platform services. You need to worry a lot less about the infrastructure that is below you. However, all of these services are built essentially on top of a proprietary control plane, so which means that you lose control. You no longer own the whole tech stack. And then if you need to move to a different tech stack or to a different provider, then you basically need to port all your effort to a new proprietary control plane. Now, if you have adopted open source services, this, of course, the effort is somewhat smaller, but believe me, it's still quite a huge integration effort. And it's not the kind of discussion that you want to have, like, are you supporting this or supporting this? Well, we're not really sure. That's not really the conversation that sells very well if you're in front of a customer whose data protection needs are high. So ideally, you would like a platform that should give you both focus and also control of your whole tech stack. So let me illustrate how we have gone around to building a portable, secure, and compliant cloud platform using Kubernetes. First of all, for those that are unfamiliar, but also for those that are familiar, let me remind you what is Kubernetes and what is the power and the value of Kubernetes. Well, first of all, it is a production-grade container orchestration engine. So it's what you would generally want to use in case you want to run a containerized application on several servers or VMs. Now, the reason why Kubernetes has kind of become the dominant solution for container orchestration is because it's community-driven and open source. And this is very important because not only that it's open source so that the source code is available, but its governance is also rather neutral. So the project itself is owned by the Cloud Native Computing Foundation, which has plenty of members, and I very much encourage you to join as one of the Cloud Native Computing Foundation's members. And the Cloud Native Computing Foundation is instead owned, is part of the Linux Foundation. So no single vendor can push their interest against the interest of other vendors. And the beauty of Kubernetes is also that while it is a laser-focused project, it is also very extensible. So it has attracted a very rich ecosystem of extensions that I'm going to highlight in the next presentation. And many of these extensions are also community-driven and open source. So basically, by adopting Kubernetes and its ecosystem, not only that you get a battle-tested solution, but you also make sure that you're not getting trapped into vendor lock-in. And this is pretty much what we have been building on. So now, since Kubernetes is not that useful by itself, you're generally having something like a Kubernetes distribution, which is Kubernetes plus carefully configured extensions in order to make to derive more value out of it. This is pretty similar to how the Linux kernel itself is not very useful. You cannot do a lot with it. But then if you package the Linux kernel together with other tools and other command line tools, operating system libraries, and maybe even a UI, then it becomes a Linux distribution such as Ubuntu, which is extremely useful to many. So this is pretty much how you should also think about Kubernetes distribution. And we were so passionate about the idea of Kubernetes distributions that, in fact, we went out and built our own, which is specialized for dealing with security and compliance issues around data protection regulations such as GDPR or national healthcare regulations. And we made sure that it comes out of the box with security best practices. We have drawn from here inspiration, not only from the European Data Protection Board, but also the NSA, the US National Security Agency, has recently issued a report on how they think it's best to secure containerized workloads. And we have taken these regulations and best practices and mapped them to ISO 27000 controls, since that is a popular framework to reason about data security and data protection in Europe. And we made it an open source project. And what pretty much we did is that for each of the ISO 27000 controls, we came out with a Cloud Native Computing Foundation project and best practice configurations in order to handle that control to a satisfactory point. And in essence, compliant Kubernetes allows you to run any containerized application on any cloud in a secure and compliant manner. And when we built this last year, the reaction was like, well, this is really cool. This is really great. You're onto something, people. But in order for me to port my application on any cloud provider, I need more than that. I need additional services. At the very least, I need something like a primary database. I need something like an in-memory low latency key value cache. This is useful either to offload the primary database or to store session information. And I often also need something like a message queue in order to decouple my foreground jobs, so those that are, let's say, API handling code, from my background jobs, those that run asynchronous in the background. Okay, so that's great. We're onto something. So then we went back to the drawing board and we thought about, okay, so how can we satisfy these needs? How can we make sure that we run these additional services that applications desperately need to run on any cloud infrastructure? And we pretty much realized that we have two options. Either we build a provider-specific support for each of these additional services, and that pretty much boils down to creating this big ball of mud, the proprietary control plane that I talked about, but yeah, maybe in an open source fashion. Or the second option, we realized that actually we can build on all of these additional services on top of compliant Kubernetes. And this has the advantage that it abstracts away the infrastructure as enabled by compliant Kubernetes. And it also allows us to reuse all of the goodies that are coming in compliant Kubernetes, such as capacity management, logging, metrics, and so on. And so, of course, being very passionate about Kubernetes distributions, we went for the second option. And we realized actually that this decision makes perfect sense and that Kubernetes is a really great engine for a portable cloud platform. So, for example, you can deal with capacity management requirements via resource requests and limits. So you can, so Kubernetes not only tracks how much capacity is available on each of the worker nodes, but you can also say how many CPUs and how much memory each of your containers requires, and then Kubernetes makes sure that they are being scheduled accordingly. And then you can also look at the metrics that Kubernetes exports in order to make sure that you have enough capacity or perhaps even reserve capacity in your cluster in case of a failover. Kubernetes also allows you to do some fine-tuned scheduling via a mechanism which is called taints and tolerations. So you're essentially tainting some nodes with a certain label, and then that will pretty much discourage most of the containers for being scheduled on that particular node. And then if you want nodes to be scheduled on that, if you want pods to be scheduled on that particular node, then you say that it tolerates those particular taints. And combined with some scheduling affinity, you can basically come up with some complicated rules, such as run the database containers on nodes with SSDs, but make sure that other containers do not run on those particular nodes. Kubernetes also offers you an in-cluster private network. So this is pretty much the equivalent of a virtual private cloud in big cloud providers. And this is something really practical if your next cloud provider doesn't offer it. And it pretty much comes with all of the goodies that you're used to from a VPC. So you have a firewall, you have internal load balancer, and you have even a private DNS in order to make sure that your application components can discover each other and can talk to each other without having to, hardcore IP addresses or whatnot. Now, Kubernetes also offers under the hood a strongly considered distributed key value store. You usually don't have access directly to it, but rather are accessing it via a mechanism called Kubernetes custom resource definitions that I'm going to talk about soon. But in essence, this is a very useful mechanism for implementing things such as leader elections, such as failover of the primary. You can also store in this key value store configuration and make sure that configuration is synchronized across replicas of a certain service and so on. And then it also simplifies a lot metrics collection and metrics-based alerting via a project called Prometheus. And similarly, it also simplifies a lot log collection and log-based alerting. We like to use the project called OpenSearch, which is, let's say, the follow-up project from Elasticsearch, but with a more permissive Apache 2 license. So in the end, what you're obtaining is pretty much compliant Kubernetes being what I like to call it the hourglass waist of your platform. Let me illustrate this metaphor with something else. Think about how HTTP acts like the hourglass waist of the internet. Below HTTP, you have various messy, wireless, and wired and mobile networking technologies that all are kind of the same, but all look very different. And they offer different performance. They work slightly differently. Some of them work with MAC addresses, some of them don't, and so on. And then on top of HTTP, you can have then a plethora of different services such as gaming, chat, video and audio conferences, streaming services, and so on. And basically HTTP acts a bit like the hourglass waist. So instead of having to, now I'm saying something pretty absurd that one could not imagine, but imagine just having to implement your video conferencing software for wired, wireless, and mobile technologies. That would be just insane. So instead you're implementing those on top of HTTP, and that then abstracts away the messy network technologies below. And that's pretty much what compliant Kubernetes also does for you. So below it, you have any kind of complex infrastructure, and you have to deal with things such as outbound traffic via NAT and how to make sure that inbound traffic comes redundantly in via something like load balancers or something via BGP Anycast and so on. But once you have configured compliant Kubernetes, then above you can run not only any platform service, such as a key value cache, database, and message queue, but you can also host your application. And judging by Conway's law, so this is law that says that the system that you're designing is very likely going to also match the skills that you're having in the communication patterns that you're having inside your organization. This also creates a very nice demarcation between the various people that you're likely going to have in your organization. So then you can say that, okay, a compliant Kubernetes administrator is responsible up to a certain point in your tech stack. Then you will need some kind of service-specific administrator that only needs to know enough about the platform services. And then you can focus on your application building on top of these platform services. And this kind of extensibility and power is enabled by something that's called the operating pattern. So essentially, Kubernetes allows you to define custom resource definitions, which are a way to extend the Kubernetes API with new objects that are not natively supported or not built into Kubernetes. Then you can define a service-specific operator, which pretty much abstracts away the boring and the tedious parts of setting up a database cluster, setting up a message queue cluster, and things like that. And in that case, you can kind of imagine Kubernetes as not only a container orchestration engine, but also like an API standard. So how do I define my APIs around setting up additional services? And let me illustrate just that for the 3 services that I commonly hear that application developers are requesting. So for example, if you want to run Postgres inside a Kubernetes cluster, we like to use the Zalando Postgres operator. And on the left, I'm having here the code, an example of a code that you would need to send to Kubernetes. And this code pretty much defines a PostgreSQL cluster, which is having 2 instances, which has logical backups enabled. It uses Postgres version 13. It has 30 gigabytes of storage. And then lower, I say that this cluster, I mean, each replica of the cluster should use 1 CPU and should be allocated 4 gigabytes of memory. And below, we also set some tolerations, so to make sure that it only runs on specific database nodes, and that there is a certain level of isolation between the nodes that are running a application and the nodes that are running a database for better capacity management. And just by writing these rather few lines of code, you're essentially getting for free capacity management. So the database cluster will run on dedicated nodes. Thanks to the features in Compliant Kubernetes, you get for free monitoring. You also get for free an audit log. So whenever an application developer wants to connect to the database cluster for, let's say, doing a database migration, or let's say for some ad hoc analytics, you're getting for free an audit log. You know exactly which user has connected at what time to what database cluster. You also get point-in-time recovery. So this is very good for your disaster recovery posture. And the Zalando operator will also take care of primary failover. And it does this by actually reusing the key value store etcd inside Kubernetes in order to make sure that, well, there is exactly one primary inside the Postgres database cluster. And you can do the same thing also for Redis. So there are quite a few good operators out there. We're using one that is from a company called Spot-A-Home. And so if you want to run Redis in a highly available manner, you need to configure it with Sentinels, and you need to have at least 3 replicas. And here is how you would send this piece of code over to Kubernetes in which the Redis operator is being installed. And that would make sure that you have the right capacity management set up, that monitoring is being enabled. So I haven't highlighted it here that well, but you also get a special exporter for Redis that then exports various metrics into Prometheus. And in case of Compliant Kubernetes, those are being caught and then sent all the way over to some Grafana dashboards. And you can also configure alerts based on that. And again, you would get high availability for free. And the nice thing is that if, for example, your cluster is configured in a way that it spans data centers, then you no longer need to deal with that complexity on the Redis cluster level, but rather Redis cluster will just naturally spread across data centers. And since Kubernetes offers a private network on top of the infrastructure, it wouldn't really matter to the Redis cluster that it's spread across data centers. It would just work. And then finally, you can do the exact same thing for a RabbitMQ cluster. Again, if you want it to be highly available, you need at least 3 replicas, especially if you want to work with quorum queues, as is recommended. And then again, you would get for free capacity management, monitoring, audit logging, and high availability. So this sounds all really nice and really cool. On a positive side, we found that this way of reasoning about your platform really allows to future-proof your tech stack. So whenever a customer to us comes and says, hey, can you run our application on-prem, or can you run application on another cloud provider, it's no longer a question of if, but it's mostly just like, okay, let's audit your infrastructure and see exactly what you offer. And then depending on that, we need to configure the platform a little bit differently in order to make sure that everything works. And what it really enables you is to eliminate those tedious and error-prone tasks. So I'm not sure how many of you have set up from scratch a replicated Postgres cluster, but there are some steps that you really need to make sure, to make sure that the primary is configured correctly, then make sure that the secondary is correctly finding the primary, make sure that they're in sync, so they're not, that the WAL files can be copied from one to another, and that there is not too much replication lag between that. There are some tedious and error-prone tasks, and just so nice if something automates those things away. And what you obtain at the end of the day is a portable security and compliance. Now, on the downside, our experience shows that you still need the right skills. So just because this code exists out there and we made it available for out there doesn't mean that, well, you can just forget the people. So you still need highly qualified Kubernetes admins that understand the whole thing. And especially if there is an incident, they know exactly what talks to what and what to investigate. But then also you need some service-specific administrators, because although it's pretty easy to configure a RabbitMQ cluster or Postgres cluster thanks to the operator pattern, very small configuration changes might have a huge impact on your security and compliance posture. So you still need the right people to understand all these trade-offs and to explain like how can to decide how can you best fulfill your security and compliance requirements with the tools that you have available. So to sum up, I see a growing need for data sovereignty, and I see that this trend is growing at an alarming rate. So therefore, I suggest everybody to start focusing more and more on on-prem, non-US clouds, and multi-clouds. I have talked to you about how Kubernetes can be used as the platform engine that on one hand allows you to focus on your application, but on the other hand allows you to control your whole tech stack. And I recommend you to check it out and let me know what you think about it. And yes, I'm available via LinkedIn. So in case you have other things that you would like to share with me, or just questions, or maybe you have other thoughts or something that I've missed out, please connect with me, and I'm very happy to continue the discussion. Thank you very much for your attention, and I'm ready to take questions now. Dennis, not sure you're speaking, but you're on mute. Okay, so I see a first question in the chat. How do you manage workload security? And to this, I would like to go back to my slides here. So we do quite a few things in order to manage workload security. First of all, you can put your additional service on dedicated nodes, so to have a better separation between the application pods and between the additional services pods. Also, compliant Kubernetes enforces that all of the pods are not allowed to run as root, so this gives you additional security. And then furthermore, there is a Kubernetes concept called network policies, which pretty much act a bit like the security groups in the VM world. So they are applied on each pod, they're selecting pods, and then they're controlling what inbound and outbound traffic is going in and out of each pod. So for example, you could set up a network policy that says all of these RabbitMQ nodes are not allowed to talk to the outside, to the internet, and they're only allowed to be to receive connections from the application pods. I hope I answered that question.
Yeah, I have a bit of noise in the background. What about, so I have sort of additional questions. Yeah. In terms of what considerations have you done? Have you looked into, for example, using or deploying service mesh along with your Kubernetes, and how will that work? As well as, you know, do you, when it comes to securing the containers apart from the features at the KX level, right? Is it just those controls that you use for container security when it comes to things around sign-in containers or artifacts, etc.? I'm just trying to understand that level of, so I understand the at the K8 level how things are working, but when you're actually putting workloads on top of something like this, and you know, need sort of more security, more segmentations, as well as more monitoring, especially if you're operating in a, let's say you want to take this in a sort of FS organization building something in the cloud, where there are a lot more stringencies around security and stuff that you need to do.
So let me try to unpack your question in several questions that I heard. So first of all, with respect to container image signing you were asking, what we allow in compliant Kubernetes is that you can configure a set of trusted container registries, and compliant Kubernetes comes with its own container registry, which also uses in the background Trivy for vulnerability scanning. And then the container registry can be configured, for example, to not allow a certain criticality of containers to run inside your workload cluster. Okay. So that's one way in which we are basically forcing all of the containers to go through a known process of vulnerability management and not allow containers to be just pulled arbitrarily off the internet. Now, you also asked about service meshes, and we are closely monitoring the ecosystem. My gut feeling is that they have certain things that are nice, like, for example, observability. They significantly increase observability, and that's why I hear mostly people asking about service meshes. When it comes to securing your workload inside the cluster, I'm not such a strong believer in service meshes. We're using Calico for network security under the hood, and it has recently added WireGuard security so as to encrypt pod-to-pod traffic with an in-kernel primitive. And in my opinion, that is that offers way more performance in order to ensure that data in-cluster communication is encrypted over an untrusted network. I do, however, hear a lot of people that they do want service meshes for observability. However, there I also feel that the ecosystem hasn't quite settled on how exactly to implement that without paying the additional performance overhead that security meshes come up with. And a pretty promising technology that is a pretty promising approach that is promoted by Cilium now is to actually use eBPF probes. So this would be low-level code that is, let's say, compiled by the kernel and runs in the kernel, but in a secure manner. And that would instead allow you to extract all the observability you need, but without paying that much overhead. So right now, we're pretty much just observing this ecosystem. And once we see that this approach is more mature, we'll very likely adopt it in compliant Kubernetes. Did I answer all of your questions?
Yeah, you did.
And as I said, for segmentation, maybe I should dig deeper into that. For segmentation, Kubernetes offers network policies that Calico, the network provider, implements. And that pretty much allows you to specify which containers are allowed to talk to what other containers. And to make sure that if one container gets compromised, you pretty much cannot do anything out of there.
Yeah, I figured you were using Calico for the policies or something similar. Yeah, thank you.
And then just in case you're curious, in order to enforce the policy where we only allow certain trusted container registry to be used, we use Open Policy Agent and Gatekeeper for that.
Okay. So just one more question. It just occurred to me again. Sorry. I did see somewhere in the slide around configuration management, but I think you didn't. Did you speak much about that? How do you sort of manage that to protect against drift?
So the drift management is the job of the operators that I was talking about. The way it works in Kubernetes is that there is a convention that all of the objects have a specification and have a status. And then the operator, when I say operator, I mean the piece of code running inside the Kubernetes cluster dealing with that particular object, is responsible for reconciling the status and to make sure that whatever real world actions are taken in order to reconcile with the specification. So for example, if I change the specification to say, instead of replica 2, replica 3, then that change will be picked up by the operator, who will then need to take the necessary decisions, such as running a new container, connecting the secondary container back to the primary, and then updating the status of the Kubernetes object to reflect that now there are indeed 3 replicas running. Does that answer your question?
Yeah.
What I was trying to highlight in this particular bullet was that these operators don't have to reinvent configuration management from scratch, which I agree with you, it's a pretty tedious topic, but rather they can leverage the key value store of Kubernetes and use the configuration management features of Kubernetes for, let's say, native Kubernetes objects, and bring those benefits to objects that are not native to Kubernetes, such as Redis clusters, Postgres clusters, and so on.
Yeah. Yeah, I don't know. I'm thinking aloud. I don't know if we have more time. Yeah.
Please go ahead. I have more time.
Yeah. So a part of the big challenge in the cloud, and I work with the cloud a lot, all different flavors. So whether it's OCI, Oracle, or it's GCP, whether it's AWS or it's Azure, right? I've worked with an OpenStack. So literally all flavors. Yeah. So
yeah, you convinced me.
So some of the big challenges with these public cloud are, there are a lot of services, right? Lots of services that are part of the public cloud. And when you're creating, for example, just take an organization creating a solution and they're putting it in the cloud, which more and more organizations are doing today, then you're potentially open to the fact that, any number of resources, it can be deployed. And as sort of a security expert and proper security hygiene, especially if you run it, and I'm speaking primarily around financial workloads, yeah. But it could be anything, right? I suppose you'd want to sort of track all those resources before, and understand what controls needs to apply before you allow them, right? So I was just looking at this, and it looks very, very interesting, because this is one of the challenges I was trying to solve with a sort of multi-cloud approach. But in terms of trying to limit deployment of resources when you move this into cloud, right? Based on let's say a static list of resources that you would allow to be deployed, how is it possible to achieve it on this platform, or will you need to do maybe some form of configuration at the cloud level to create that limitation in terms of resources that can actually be deployed from a specific cloud provider?
So you're asking whether it's possible to limit the kind of additional services that are being created inside the Kubernetes cluster. Do I get your question correctly?
Yes. So I only want specific services that I've vetted and validated and applied, whether it's guardrails or controls, right? To be deployed.
Yeah. So actually, the way we're currently running compliant Kubernetes is that we're not giving the application developers access to run these kind of additional services, because, like I said, my opinion is that you need a service-specific administrator which understands the subtle configuration trade-offs and how that impacts your compliance and security posture. And the way we achieve the fact that you have some compliant Kubernetes users that can create these objects and some cannot is via Kubernetes mechanism called role-based access control. So what happens is that we're integrating compliant Kubernetes with an organization's OpenID provider, and you're using your OpenID credentials in order to log in to compliant Kubernetes. So then your email address and, let's say, the groups present in your JWT token are exposed to the Kubernetes role-based access control machinery. And from there on, you can pretty much map all kind of rules. You can, for example, say that this particular group is allowed to create a deployment, but is not allowed to create an ingress, or on the contrary, is allowed to create an ingress, a deployment, and a service, but only in this particular namespace. And you can say that this other group is allowed to have access to Redis or to create Redis objects, but not this other group. And it's a very rich language for access control that maybe I should have talked a little bit more about this. I kind of agree that this is a missed opportunity, but it pretty much allows you equally to control which of these additional resources and additional services get to be created by whom. So it's pretty standard Kubernetes role-based access control.
All right. Okay.
And you can even bring it to the level where, for example, the way we're doing it is that often almost all of compliant Kubernetes users are allowed to view all of the resources, or at the very least list all of the resources, but not everybody gets to change them. And that's also something that, the Kubernetes role-based access control allows you fine-grained permission management for each of the roles you're defining.
Okay, thank you.
If I now I'm a little bit rambling, but you could also push this concept as far as, for example, to have network security specialists that can define your network policies, and let's say everybody else can view the network policies but not change them, so as to, let's say, have an even better separation of responsibility, like those who deploy code versus those that decide what code talks to what other code versus the service specific administrator. So that can be arbitrarily mapped depending on what your organizational needs are.
Thank you.
Hi, Christian. Can you hear me?
Yes, hello, I can hear you. Oh, hi,
Hi.
Simon.
Hey, how you doing? I saw your talk on advertised on LinkedIn. I thought I would just check in. It's a little early here, so I will not enable my camera. I had a question for you. You said, I think you guys are actually hosting these as a platform as a service, so that customers can basically rely upon you to administer and provision things, and then they can put their software on top of that at the application layer. How do you deal with the issue of, their data is secure and secret to them, but your operator administrators could actually potentially see that? How are you going to handle that?
That's a very good question. So first of all, let me say that when it comes to security compliance, I don't believe that only technical measures are going to work. So we're also, if I really want to give you the whole story, we're also investing heavily in making sure that we're recruiting the right people, that we are fostering the right security culture, and also that we're keeping our people, happy, so as to make sure that they wouldn't, an insider job is unlikely. And I have seen this pretty much in other organizations too, right? I mean, you could either force people to rotate their passwords every month, or you could just as well educate them on why it's important not to have their passwords on stickers everywhere. So I have actually seen an organization which found it more effective to have on each of their microwave oven a pretty colorful banner. I assume that the marketing department was involved, explaining them why sharing is not caring when it comes to passwords. And that was a way more effective security measure than coming up with, I don't know, forcing the users to rotate the password every week or something like that. So security needs to start from there, and that's also where we're starting it from. And then we have also other security measures that we put in place. So for example, we have individual users for all of our administrators, and they have, even though they have special administrative access to the cluster, as you highlighted, right? Because they need to upgrade the base operating system, they need to upgrade compliant Kubernetes components, so they have a more privileged access, but their access is individual. And even if they are changing something in compliant Kubernetes, that leaves an audit trail that is then being sent to an S3 bucket, and that operation is being stored. And then we're having a log review process in which we regularly go through these kind of procedures. And then if we notice that, okay, some kind of activity has happened without an associated change log or without an associated operator log happening, then we can look into it and investigate. So I'm not sure if I gave you a satisfactory answer, but pretty much our approach is trust but verify when it comes to security.
Yeah, that's a good answer. The other thing, of course, is confidential data, say in the database. Is it does the Postgres SQL that you supply, is it possible to have encrypted REST data there so that it can't be decompiled by an administrator? Do you go to that length of extreme, or is it like, if you sign up for the service, then you've got to trust our administrators not to do the things that they could do, but we'll watch them and verify that they don't?
Yeah, exactly. So we do not do encryption of the database. If our customers choose to do that, that's of course their choice, and it might be a good choice in certain cases, but not in others, because it tends to bring other problems, and I can talk about that too. But what we do is pretty much, as you said, we just train our people why it's important that they don't just mess up with data. We make sure that we have the right audit logs in place so as to be actually able to verify if anything wrong has happened. And afterwards, we are bound by, in Europe, if you're dealing with personal data, you have to sign a so-called data protection agreement that pretty much binds us as a company to stick to the highest security standards when it comes to data. And that, of course, in turn puts pressure on the organization itself to make sure that our people are trained properly and that they are that we have the right safeguards in place to make sure that data is handled responsibly. Now, there is the other option that you just highlighted. It's called end-to-end encryption. Some companies have gone as far as to encrypt personal data on your mobile phone, send it encrypted to your application, and then basically everything is just pretty much random and opaque to everything that's down the tech stack. The problem that I'm perceiving with this kind of approach is, first of all, that it's pretty tricky to get it right. I mean, what do you do if the mobile phone gets lost? Well, in that case, you kind of need to store a backup of the encryption key. Okay, what do you do with that one, right? So you're still having a little bit of a hard trade-off to take between. It's really difficult to design a system that is both good at forgetting and is both good at remembering, and then you have to take some trade-off and choices. And the dominant approach in Europe is pretty much to sign data protection agreements and make sure that security requirements are propagated down the supply chain.
Yeah, I think that makes sense. That makes you then a part of the company that you're servicing, effectively legally. And so you have a vested interest in both working together to keep the data secure and make sure that things don't go awry.
Exactly. And by the way, we are also signing such data protection agreements with the underlying cloud provider. So in case they are not sticking to, I don't know, let's say that they're just handing out the keys to their server rooms to anybody on the street. Well, in that case, they would be in huge trouble, first of all. And secondly, we also realize that it's kind of inefficient to deal with security requirements at the wrong level. So while it might be very tempting, for example, to start, I don't know, encrypting your memory or to kind of use erasure coding in order to spread data apart and to kind of reduce the likelihood of people being able to steal hard drive. In my opinion, if your cloud provider is not responsibly destroying hard drive, the choice is very simple. Change cloud provider. If you cannot trust them with that, you will have way bigger problems down the line. So my suggestion would be to spot these kind of security issues at the right level.
Yeah, and you can also flip your model over. Excuse me. You can also flip your model over where your stack is being hosted on premises, but you've got the expertise to deploy and administrate it on a needed basis. You need to go in there and do things periodically, but the rest of the time you are disconnected from it. So I think that's a very sensible model. And people with high security requirements can actually host the software on their own hardware.
Mm-hmm. Yeah, exactly. We're actually having a few customers that have asked us for that kind of thing. So basically just on-demand access, they would kind of look over the shoulder on what we're doing. And this way they don't need to trust us. We don't need to sign a data protection agreement with us. But on the other hand, they would stick to their security and compliance requirements. But then let's say that the pressure is on them to make sure that everything is as secure and compliant as needed.
Yeah, I think that's a good approach. Thank you for your presentation.
Thank you for your questions.
Any last questions from anybody else? No, I think we're all done then. Thank you very much, everyone, for joining.
Thank you very much, and thank you for the great questions, and thanks again for inviting me.
Great work,
Thank you.